This problem will again look at tables of proportional relationships. One of the tables below represents a proportional relationship between x and y. Which table represents a proportional relationship? So in order to determine if we have a proportional relationship, we need to divide our y values by our x's. So let's begin with table A. Let's take 6 divided by -3. That gets us -2. Now let's take 2 divided by -1. That also gets us -2. -8 divided by 4 also gets us -2. There we go. And -10 divided by 5 also gets us -2. That indicates that table A is going to represent a proportional relationship since we have a constant ratio. That being said, let's take a look at table B and just show why this is not proportional. So if we take 4 divided by -2, that gets us -2. But when I take 5 divided by, that ends up getting us -5 for our solution. That is not a constant ratio, so what we notice is that we don't have a constant ratio in table B, which means the table that represents a proportional relationship will be table A. Now, the second part of this asks us to write an equation that can be used to represent the relationship between x and y in this table. So since table A is proportional, it's actually really easy to write an equation to represent this. The equation is always going to be of the form y equals kx. K happens to be that constant ratio. So a simple equation we can write to represent this is that y equals -2 times x. Sometimes we will use different variables instead of x and y if we know what those variables represent, but we don't here. So we're just going to stick with y equals -2x. Now sometimes I will have students who will say to me, well, I notice a pattern in this table B, so can't we write an equation to represent that? We can actually, but it's not going to represent a proportional relationship. So I actually notice, because I created the table, that our y values are always 6 more than whatever the x values are. So -2 plus 6 gets us 4, -1 plus 6 is 5, and so forth. So we could technically write an equation y equals x plus 6, but once we throw addition and subtraction into that expression or that equation, it's no longer a proportional relationship. Remember that a proportional relationship equation is always going to be of the form y equals a number, which happens to be our unit rate, times another variable. So it's got to look something like this, which can help us eliminate choices that don't make sense. For example, if it's multiple choice and some equations are set up like y equals x plus -2, we know that can't represent a proportional relationship. Just some things to keep in mind as we think about tables and even graphs of proportional relationships.